Hi, this is Thomas. Welcome back to Algebra 2. This is part 4 of the lesson on the binomial expansion. In this lesson, we'll learn how to use the general term to calculate any particular term within a binomial expansion. So if our binomial is a plus b to the power of n, then the general term rule is t subscript r plus 1 equals the binomial coefficient n over r times a to the power of n minus r times b to the power of r. Now notice that in this video I'm using a and b to represent the two terms of the binomial. Previously I was using x and y. You could use p and q, e and f, any two variables that you like to represent those two terms. Now before we go to our examples, one point of clarification is important. We use the general term rule to find the r plus 1 term. Now what that means is if we're looking for the fifth term in an expansion, then r plus 1 equals 5, therefore r would be 1 less than 5, or 4. If we're looking for the 12th term in an expansion, r plus 1 is 12, therefore r would be 11. So notice that in the general rule we'll need to input r in 3 different places. So it's important to understand that when we're looking for a particular term in a binomial expansion, the r value is going to be 1 less than the term number that we're looking for. Now let's look at 2 examples. Our first binomial, 3x minus 4 over x squared to the power of 14, and we want the 7th term of the expansion. We can observe that a is 3x, b is negative 4 over x squared, and n is 14. Now we're looking for the 7th term, which means that r plus 1 equals 7. Therefore r is 7 minus 1, or 6. And now we can input our terms into the general rule to derive the 7th term of this expansion. Starting with the left side of the equation, t subscript r plus 1 is t subscript 7, the 7th term, equals the binomial coefficient n over r. N is 14, r is 6, times a, which is 3x, in brackets, to the power of n minus r, 14 minus 6, times b, which is negative 4 over x squared, in brackets, to the power of r, which is 6. Now if our requirement is to find the particular term in unsimplified form, all we need to do as a final step here is clean up the exponents. 14 over 6 times 3x to the power of 8 times negative 4 over x squared to the power of 6, and we're done. And for this type of question, the most likely requirement would be to derive the term in unsimplified form. If you wanted to further simplify, then you identify your constants, which are the binomial coefficient 14 over 6 times 3 to the power of 8 times negative 4 to the power of 6, and then you identify your variable terms, which are x to the power of 8 and 1 over x squared to the power of 6. Here we'll leave our solution in unsimplified form and now move on to our second example. Our binomial is x squared plus 4 over x. The expansion is to the power of 12. And the requirement is to find the coefficient of x to the power of 6. So in this case, we're going to use our general term to identify where x to the power of 6 is in the expansion, and then calculate the coefficient for that term. Now we'll begin with the general term, but we're going to have some gaps because we don't know which term it is that we're looking for. So let's begin with t subscript r plus 1 equals n over r. Now we know the n is 12. R is unknown, so we leave it as a variable, times a. A is x squared, in brackets, to the power of n minus r. Again, n is 12, and as of now, r is unknown, 12 minus r, times b. B is 4 over x, to the power of r. From here, 12 over r times x to the power of, first, 2 times 12 is 24, minus, next is 2 times r, or 2r. So we've multiplied 2 by 12 minus r, times 4 to the power of r, times 1 over x to the power of r. And now we will group the variable terms, 12 over r. Next we'll have our constant, 4 to the power of r. Now we'll group the variable terms. We have x to the power of 24 minus 2r times 1 over x to the power of r. 1 over x to the power of r is the same as x to the power of negative r. Let's do this in 2 steps. We can now see we're multiplying x to the power of 24 minus 2r times x to the power of negative r, which is the same as 1 over x to the power of r. And to simplify from here, 12 over r times 4 to the power of r. Now, x to the power of 24 minus 2r times x to the power of negative r. We want to add the exponents because we're multiplying and we have the same base. 24 minus 2r minus r gives us x to the power of 24 minus 3r. Now, remember the requirement is the coefficient of x to the power of 6. So relating to the requirement, the coefficient of x to the power of 6, we've calculated x to the power of 24 minus 3r. We'll set an equation, 24 minus 3r equals 6, and then use the resulting r value to complete the general term. So, 24 minus 3r equals 6. We can subtract 6 from both sides to get to 18. Add 3r to both sides to get the right side of the equation to 3r. And then when we divide both sides by 3, r equals 6. So we'll take our incomplete general term with the input of an r value of 6. For the equation, the t subscript r plus 1, 6 plus 1 is 7. The 7th term is binomial coefficient 12 over 6 times 4 to the power of 6 times x to the power of 24 minus 3 times 6. Now the requirement is the coefficient of the x to the power of 6 term. So x to the power of 24 minus 3 times 6 isn't directly important for the answer, but we do want to check what our simplified x exponent is to make sure we have in fact found the term with the x to the power of 6 as part of the term. So x to the power of 24 minus 3 times 6 is x to the power of 24 minus 18, and that is x to the power of 6. So as a confirmation, I'm going to note that, but that isn't a part of the answer. The answer is simply the coefficient. And when we simplify the binomial coefficient 12 over 6 times 4 to the power of 6, we end up with the value 3,784,704. So the seventh term is 3,784,704 times x to the power of 6. But the answer to the question, the coefficient, not the entire term, simply the coefficient, is 3,784,704. Now we'll finish up with some terminology clarification. In a scenario similar to our second example, we're looking for a particular coefficient. That is the coefficient of x to the power of 6. If you're ever asked to find the constant term, process is very similar to what we're doing in our second example. Another way to think about the constant term, which means there is no x value, is the constant term is the term with the coefficient of x to the power of 0. So if you work through the process as we've done in our second example, looking for the coefficient of x to the power of 0, then you'll solve for the appropriate r value, plug that in to complete your general term, and then the coefficient that you calculate will be the entire term. There will be no x value with that coefficient because that x value is x to the power of 0. Thus, solving for the constant term procedurally is the same as solving for the coefficient of x to the power of 0. This concludes the lesson on the binomial expansion. These are some advanced concepts, and the only way to learn them is by practicing them, so make sure you do so. Thanks for watching, and I look forward to seeing you in the next lesson.